My name is Jonathan Regalado-Hawkey from Valens Semiconductor, and we're here at Embedded World 2025 in Nuremberg. One of the growing problems of basically PC-based cameras is how to operate in an industrial machine vision industry. What I mean by that is the challenge of basically immunity from external noise. So very high levels of noise in a factory floor, as an example, as in agriculture, in medical, and how do we overcome those systems from taking it all the way from the camera all the way to the processing the PC itself. In this particular demo, we have basically two setups. We have one using a legacy device of a second generation SerDes communication working up to 6 gigabits per second. And then we have a second unit where we're showcasing the same camera. Again, both of them operating at 4K 30 Hertz resolution. And this one's using MIPI A5 along with the Valens VA7000 chipsets. Now, along this link, we're also basically injecting a noise, and it runs through basically a range of frequencies starting from 0 up to 5 gig. And what we start to do is basically increase the level of noise that's been injected to both signals, and to see at what point do these serializers and deserializers start to fail, how much the link starts to be affected by the external noise. Currently, the system is operating at minus 11 dB, and as you can see from the both images, they're perfectly working fine, very reliable and stable. If we now increase the system noise up to 0 dBm, the system now already immediately starts to fail on the legacy device, and you can see on the MIPI A5, it's working flawlessly. Now, let's see how much further we can push that link system to. I'm going to increase it by another 10 dBs. So the system now is operating at 10 dBm. And as you can see, the link is perfectly stable. Obviously, on the other side, it's failed and it continues to do so. Let's push it further, another 10 dBs. So in this case, I've put it to 20 dBms. And the system continues to work flawlessly. I'm going to increase it a little bit further. Let's say another 5 dBs. And you can now already just about see the stuttering, and it's gone. So the difference between the legacy device of a 6 gigabit per second system and a MIPI A5 working at 8 gigabits is actually more than 20 dBs difference of noise working between one system and another. That allows you to use different types of cables, be much highly reliable against external noise, and basically a system that is accurate and is able to work in very robust and highly noise systems out there, as I mentioned, like agriculture, factory automation, medical, etc., etc.